Welcome back to section 12.4. We're getting started with an exploration, so pause right away. Take a look at this trapezoid, use everything we learned in the previous section, and then press play when you're ready to move forward. So we're continuing on with example 3, and we're going to look at trapezoids. So in example 3 here, this problem is designed to help us find a formula for the area of a trapezoid and explain it in several different ways why it's valid. So you explored this a little bit. Let's formalize it together. So show how to combine two copies of the trapezoid in this figure to make a parallelogram. All right, so we're going to take two copies and form a parallelogram. Then we're going to use the formula for the area of parallelogram to figure this out. So basically what this wants us to do is it wants us to make two copies of this. And I'm going to see my drawings, as you know, are not always so great. But essentially what they want us to do is flip this. And let's send this one. Let's see if we can. Oh, it's going to be difficult. But you see the idea here that we're trying to kind of build this parallelogram. Can you see it now with my outline? Okay, and so over here, we've got, and if you can just kind of imagine that that shape is filled in to match. All right, and I'm gonna move all of that over so we can keep our work for the next problem as well. Okay, so now we've got two copies of the trapezoid, like they said, and we built a parallelogram. So when we look at this parallelogram, we see that for the area of a parallelogram, it's base times height. Well, the base of this is a plus b. So our parallelogram is the a plus b, or b plus h, however you want it, b plus a. And the height of this parallelogram is h. Now, that is the area of this parallelogram, but what about the trapezoid? Well, the trapezoid, these are two trapezoids, so we want just half of this. And that is the formula of the trapezoid. So it's 1/2, and one way to look at this is, so B is this side length, so that's one side length, and A is the other side length of the trapezoid. So it's the sum of the side lengths times the height. All right, let's look at if we can prove it another way. Show how to cut off portions of the top part of the trapezoid and combine these portions with the bottom of the trapezoid so as to make one or several parallelograms or rectangles, each of which has one side of length 1/2 h. So they want us to cut this in half so that each thing has 1/2 height here. So if I look at this little triangle here, if I were to put that little triangle right there, and if I were to take this and extend this out, kind of putting that right there. And just so you know, I am going to have the computer versions of these images so you can study those on the next page, because I know that my drawings are not perfect. And again, I made a little mistake here. So I've got this triangle already accounted for, so I'm pulling this shape here. So this edge is going to go right here. And then I'm going to get that edge is this edge right here. So this is, remember, 1/2 h. We made it that way. We cut off half. And then this side length here is A. So now I have a rectangle. Let's make it highlighted so you can really see this full rectangle. So a rectangle formula is just length times width. Well, the length of this is A plus B. And the height of, or the width of the rectangle is 1/2 h. So if I was to reorganize it, so again, we're getting the sum of the sides of the trapezoid times the height. Let's look at it another way. So now they're subdividing the trapezoid into two triangles. They want us to find a formula in terms of A, B, and H for the area of the trapezoid. So if we look at this, I'm just going to call this A triangle and this B triangle. And I just want to make sure you can really see A and B. So now let's find the area of A. Well, we know it's going to be 1/2 base times height. What's the base? The base is A. And if I was to find the height of this guy, So here's my base. I need to connect it to this vertex. So, and it needs to be perpendicular. So it's going to be, maybe I come out this way, right? And that height here is the same distance as this. So it's going to be, the height is h. So what's the area of B? We know it's going to be 1/2. Let's call the base B. And we can see here that it connects to this vertex perpendicularly at h. So the total area is going to be 1/2 AH plus 1/2 BH. And if we were to factor out the common pieces, so 1/2 in H, 1/2 in H, we would be left with A plus B. So again, it's 1/2 of the sum of the sides times the height. So they want another method here. I am running out of space, but I think I can make this work. I'm going to pull this out over here so I have a little more space. So besides these methods, can we find another method? And the answer is yes. There are so many methods of thinking about these. And remember that when you're dealing with your students, if they're not understanding something, there are lots of different ways you can represent this material. There is no one right way to do math. So what about if I enclose this into a rectangle? That's something we often do, but we haven't done yet here. So let's enclose this into a rectangle. And now let's see here. So this is A. And the whole length of this is B. So these little extra pieces here, these extra pieces are B, all of B, take away A, right? So those extra pieces, these are B minus A. So if I was to make a triangle, if I was to kind of take these two pieces and put them together to make a triangle, it would look something like this. Let's actually call this X and Y just so you can see how I put them together. So I'm going to take X, I'm going to flip it the other way. Call that X, because I want the backs of these to kind of meet. And then I'm going to have Y exactly as it is. Now, this is the full rectangle. Take away these extra pieces, X, Y. So I know that these full lengths, remember this yellow piece here, all of these are B minus H. B minus A, excuse me. And that is the base. And I know that this height here is H. So the area of this triangle is 1/2 B minus A times H. So now what is the full area? So I'm just going to kind of make a little space here. Okay. So the rectangle minus the triangle, that is going to give us our trapezoid. So our rectangle is base times height, or length, B times H, so BH, minus 1/2, and let's just distribute this out. Let's give each term a 1/2 and an H. So that's minus 1/2 BH plus, if we distribute, 1/2 AH. Well, let's see about this. What's 1 BH minus 1/2 B is just going to be 1/2 BH plus 1/2 AH. And if we factor it back out, we get the same thing. Whew. So I'm gonna show you over here so you can kind of see it a little more clearly, and maybe that will help you understand a little bit more of what we did here. So the idea is that we can use everything we've learned so far and apply it and extend it to other polygons. Let's do one more example together. So determine the area of the shaded region, and all I've done is just make this shaded region a little bit bigger. So I'm going to look at this shaded region as two triangles, and that's just a choice. Maybe you want to look at it differently. And you know, I'm going to use my ruler just to help me here, because I'm sure that helps all of us if I can make straighter lines. Okay, let's see. All right, a little better. All right, so this triangle, let's call it A, and let's call this triangle B. All right, so now we know how to find the area of triangles. Let's find the area of A. So that's 1/2 base times height. Well, what's the base? Well, we can pick the base whatever we want. I'm going to pick the base to be 4 because I see that I know that length. So I'm going to say that's times 4. Now, what's the height? The vertex that I'm not touching here is right here. And I need a perpendicular line from this base here, so I actually can see that my height is 1. So the area of this triangle is 1/2 times 4 is 2 times 1 is 2 centimeters squared. Let's look at the area of B. We know it's 1/2 base times height. Well, we know this base, so I'm going to pick this because we know that it's 3. So times 3. Now remember, we want to connect it to a vertex not on the base perpendicularly, and look, they've done that for us, and we get a height of 5. So we want 1/2 times 15, or half of 15, which is 7.5 centimeters squared. So the total area here is A plus B, which is 9.5 centimeters squared, or square centimeters. And here it is again written out if that helps. You go ahead, give these two a try, press play when you're ready to see the solution. And that concludes 12.4.